So unsaturated hydrocarbon, here is the angle strain due to, in case of carbon double bond carbon, what we have, suppose the two hydrogen is here, the degree in between this carbon and what? 120 degree. And here we have triple bond in which angle in between is 180 degree. So this is due to angle strain. Alright. So angle strain is the one reason or main reason for reactivity. Here is the very less strain is there. Here is somewhat strain. Here is somewhat more strain. That is, in case of alkane, what we have, you will deal with the hybridization. We will deal together hybridization in chemical bonding. But here just see, for your sake of simplicity, this carbon is sp3 hybridized, while this carbon is sp2 hybridized, and here in case of that is sp hybridization is there. Now here the main reason for reactivity is the angle strain. So here see in case of alkene, in case of alkyne and alkene, which one have a double bond, triple bond, one bond. Here one sigma bond and another is pi bond. One sigma and other two is the pi bond. Here one is the sigma and everywhere is the sigma bond. Now next is the nomenclature of hydrocarbon only. Nomenclature of hydrocarbon. So IPSC, or you can say first, there are on the basis of degree 1, 2, 3, what are they? I have to deal with the primary, secondary and tertiary carbon. So when a single carbon have atom attached with single carbon is the primary. Suppose here is this one is the primary carbon or 1 degree carbon. See, if the carbon have some branch, here again carbon atom is there with the carbon. So this carbon is a 2 degree, suppose that 2 degree carbon. If we are going to take care here again a carbon, then it will 3 degree carbon. One carbon is here, another carbon is here, another carbon is, then it will be 3 degree carbon. Alright? And if we are going to take again have a single carbon again further, then this is 1, 2, 3, 4. Then this carbon will be the 4 degree so-called neocarbon atom. Primary, secondary, tertiary and what? I'll repeat once more. When a carbon atom in between them have a 2 carbon atom linked with another carbon, it will be the secondary. If there are 3 carbon atoms with a central carbon atom, that is 4 degree. So see here again for more clear. If with the example you can say, suppose that we have an example of CH3 carbon atom, again carbon, here may be hydrogen, again carbon, then carbon, again carbon. See, you can see this is the one carbon or 1 degree primary carbon. This carbon is a carbon in between here and there. This carbon attached with a carbon here. Again, the next carbon is here. So this is the 2 degree carbon. See, it's not 3 degree. This is the hydrogen, right? So it's not considered like it. What I am trying to say is, this is the primary one. This carbon is the secondary one. Why? Here is the carbon and here further is the carbon, right? If you have hydrogen, doesn't matter. इस हाइड्रोजन से कोई मतलब नहीं है, कार्बन कार्बन से जुड़ेगा, then it will be go for the degree, right? So अगर आप ब्रांचिंग करते हैं, see here we have again carbon, here also carbon, also carbon. So if this carbon attached with another further carbon, right? So how many carbon on the periphery? 1, 2, 3. So this one will be the what? 3 degree carbon. Suppose that here we have a CH3. So this carbon atom is the 3 degree. Again, if the carbon attached with the carbon on the everywhere or four valency of its attached with the main or other carbon, so can I say this carbon atom is the what degree? 4 degree carbon. Isn't it? So because of due to the presence of carbon atom everywhere with the atom. So this carbon is known as neocarbon or quaternary or 4 degree carbon. Are you getting? समझ आ रहा है? सीधे कार्बन चारों तरफ से कार्बन से ही जुड़े हैं. That's why it is a 4 degree or quaternary. Right? So here we have a 3 degree. Why? One carbon atom is here, another is in this side, and another is this side. So that is how 1, 2, 3 degree carbon atom. Here is a 2 degree. Why so? Because of here one carbon atom and another side one carbon atom. Here is not carbon, right? Here is the hydrogen only. So there is only 2 carbon atom attached with that. That's why this carbon atom is 2 degree, right? And here is the only one because of one carbon atom is going to be touched. So primary, secondary, tertiary, and neocarbon atom is like that. 1, 2, 3 degree carbon. Okay? Is there any doubt? Fine. So now nomenclature, you must have learned that 1 degree, 2 degree, 3 degree, that is primary, secondary, tertiary, and quaternary. Why quaternary? Quaternary because of presence of 4 bond with the carbon or 4 carbon atom attached with the central carbon. So that is why quaternary or tetrahedral. So now next is IUPAC. What do you mean by this IUPAC? Anybody? International Union of Pure and Applied Chemistry. So here is the Union of Chemists, International Union of Pure and Applied Chemists. Right? So IPSC give you the rule how you go for the nomenclature of alkanes. So alkanes have the formula of this one, the suffix for alkane is the ANE. Number of carbon atom. Carbon atoms, and that after ANE is the suffix. Here is the prefix. Number of carbon atom. Suppose that you have 1 number, 2 number, 3 number carbon atom, and here is the suffix with the A now. Suppose we have a 1 carbon atom. So what should be the name? Meth, right? 2 carbon atom. What should be the name? Eth. And carbon number 3 is the pro. So here you have to add ANE as suffix. Like for meth, the nomenclature for that single carbon is the methane. Name for that. If you have a 2 carbon alkane, then it's going to be called as a ethane or ethane. If you have a 3 carbon number atom, what should be the name? Propane. If you have a 4 carbon atom, meth or bute plus A and E, that is butane, like and so on. Now this is one thing. But how we'll get the another example and naming for the compounds? Just see over. If you have 4 carbon atom here, CH3. Now we are going to deal with the example CH3, CH2, CH2, CH3. Give the name. What is the name for that? Anybody? See how many carbon is there? 1, 2, 3, 4. So how many? 4 numbers. That may be but. And suffix for ane. So can I say this is the normal butane? Normal why? There is no branching. There is no branching. Maybe right. If you have this carbon, if you have this carbon at the branch here, what I'm trying to say is that if this carbon is not here, it's going to be the branch. So suppose that here is no carbon again. Here is the only one bond. So the carbon number remains same. This carbon atom I have taken here. Carbon number is the same again. 1, 2, 3 and 4. What should be named? This is the branch. This is not a normal butane. This is the not a normal butane. This is a branching. Carbon number remains same. 4 carbon number is there. But here is the branching. So this is the isomer of butane. Isomer of butane. When I say it's the isomer, what do you mean by the isomer? Isomer is the compound have same empirical formula but different structural formula. What is the empirical formula for butane? Suppose that butane is there. What is the formula for that? For butane, C4H, how many hydrogen? C4H2, and that is 4 into 2 that 8 or plus 2, that is 10. So this is the normal formula for butane. Right, empirical formula, molecular formula can I say? So molecular formula for butane is the C4H10. May I write in this way? Earlier I was there, I had given you example of the normal butane. Now I had replaced this carbon atom. Suppose that here it was normal butane, okay? Again I'll just repeat what I had done. Here it was CH2. Then this is the normal butane. Can I calculate the number of carbon? Carbon number is 1, 2, 3 and 4. And how many hydrogen is there? How many hydrogen is there? 10. Just calculate. 3 plus 2, that is 5, plus 2, 7, plus 3. How many? 10. So formula is the remain same of the butane. Is the molecular formula. Alright? Or you can say empirical formula. So empirical formula, molecular formula for butane is the 4 and 4 carbon 10 hydrogen. But in the case of structure, if we are going to deal with the, here is the normal butane because of every carbon atom are attached together with a single bonding. So called normal butane. Okay. So what is toss? If I change this position of this to somewhere else, here, suppose that I have touched this carbon here, so one hydrogen atom will be replaced where? Here. And I had given you this CH2, I had replaced to here. So CH2 plus this one hydrogen makes CH3. So when I write in this way again that this is the again butane, right? Carbon 1, 2, 3, 4, and hydrogen how many? 3, 3, 3, 9 and plus 1, that is 10. Formula is the remains. पहला जो लिखा था उसका भी C4H10, and right now I have deleted right now just again isomer of the butane. So here again the same formula. Hydrogen number is 10 remains, carbon have 4. So can I say the This is the. May I come to know from your side that this carbon is what degree? This carbon is the primary, secondary, or tertiary. What? Tell me. How secondary? Because of here carbon, here is again carbon, and here is again carbon. This is secondary or tertiary? 3 degree carbon atom is there. Why so? Because here is again a carbon, here carbon, and so this carbon attached like this one. Carbon, carbon, carbon. So it makes 3 degree. Right? So in the normal manner, can I say this is the secondary butane? Right? Secondary alkene. So for secondary, here is the what? Is the number for that. In normal way, we can say this is the isobutane. Iso means branching. Iso means branching for that 2 degree. When I say this is the isobutane, because the butane remains same. Iso but somewhere about branching is there. It is a normal name. But in case of IPSC, this is the now we must have the numbering. So number given have to. Numbering start from the first carbon that have a simple one. There may be no branching. Start numbering from where? From normal carbon atom. So start numbering from here. Longest chain. Longest chain rule says that start numbering from the longest number. From where you can calculate the longest number. So here suppose that 1, 2, 3, 4. So from where will start the numbering? यहाँ से numbering start करें यहाँ से या यहाँ से? See, tell me. Suppose that we have a single bond. Numbering will start from where there is a nearest branching. So from where will start the numbering? किस कार्बन से नंबर देते? C from here and from where will start? इसको नंबर 1 कार्बन कहें या इसको कहते हैं या इसको कहेंगे? Anybody? So start numbering from where the branching is remains nearest. Branching start है इस कार्बन से, right? एक कार्बन इधर है, एक कार्बन इधर, कार्बन इधर. We are free now. Now we are free from where anywhere से आप कैलकुलेट करेंगे. You will get the number 1, 2, 3. Either change the number 1, 2, 3. It's 2 numbers remain same, or 1, 2, 3, or 1, 2. कहीं से भी चलेंगे इसमें चारों कार्बन पे 2 डिग्री रिमेन सेम आ रहा है, राइट? तो अभी आप इसमें P है. नाउ यू आर एबल टू कैलकुलेट फ्रॉम एनीवेयर बिकॉज़ इन केस ऑफ 4 कार्बन. So let's start with the longest rule. May I give the name for that? What should be the name? What should be the name for that? Isobutane, what I told you. But in case of IPSC, this should be not be there. Isobutane will not be there. So may I write in this way the number of methyl group here. अभी आपको एक सिंगल चेन मिली 1, 2, 3 और 1, 2, 3. This is the 3 carbon atom. 3 carbon atom for alkane. What should be the name? That is a propane. Fine. And what is in the case of side? This is suppose our side carbon atom. Longest chain is there. लंबी चेन इधर रहेगी, उधर का ही नोमेनक्लेचर लेंगे और साइड को छोड़ देंगे. तो दिस इज द वन साइड कार्बन एटम. ये साइड में है. लॉन्गेस्ट चेन 1, 2, 3 बना. या 1 मिनट, अगर आपको इधर से जाना है 1, 2, 3 ये साइड हो जाएगा उसके लिए. ऐसे चलेंगे तो राइट. इधर से आएंगे 1, 2, 3 तो ये साइड में होएगा. अगर हम इस तरह से स्टार्ट करते हैं 1, 2 and 3 then this will be in the side. My question is like that. जो ब्रांचिंग है, longest branching you have to take. longest branching कार्बन आपको लेना है और साइड में जो छोड़ता है उसको छोड़ देते हैं, राइट? छोड़ने के बाद नोमेनक्लेचर करते हैं. सो अगेन आई रिपीट दिस कार्बन एटम, द सिमिलर ब्यूटेन. longest rule numbering we have CHP. here CH3, here is CH3. So 1, 2, 3 bond is there. Only one hydrogen is remains. अभी आपको लगना नहीं चाहिए ये साइड में आ गया तो इट्स नॉट अ कार्बन, ये तो हाइड्रोजन है, इसकी नंबरिंग का कोई मतलब नहीं है। नो, इससे हमारा ये नियो बनेगा। 22 तो ये कार्बन होता है, नियो कार्बन 4 डिग्री कार्बन हो जाता है। तो दिस इज द ओनली 3 डिग्री। So hydrogen has no meaning for the carbonic numbering of carbon. So here 1, 2 and 3 carbon atoms called what? Prop, isn't it? 3 carbon atom called prop and plus this is the one N, propane, and साइड में एक कुछ छूट रहा है ना। 1, 2, 3 का नाम दिया, 1, 2, 3 का नाम दिया। What is the fate of this methyl? So I can say this carbon के लिए हमको कहना है क्या? Methyl. How many methyl? 2 secondary, 2 कार्बन पे, 2 नंबर कार्बन पे ये लगा है। May I write in this way? 2 methyl propane. 2 methyl propane. Why so? Because of this is one inside. So one carbon is here, 2 methyl. And their calculation of the fourth one. So here I had told you the methyl. What is the methyl? Just take care of this alkyl group. So alkyl group, I'll just explain here to you. What do you mean by the alkyl? Alkyl group. See, if you have formula of alkane, जस्ट रिमूव वन हाइड्रोजन फ्रॉम द नार्मल, एक हाइड्रोजन कम कर दीजिए, देन इट शुड बी व्हाट? इफ यू आर गोइंग टू टेक केयर ऑफ -1 हाइड्रोजन फ्रॉम द फार्मूला, एक हाइड्रोजन रिलीज करिए नॉर्मल फार्मूला CnH2n+2 से 1 माइनस, या तो ये कर दें आइदर और इन अनदर वे CnH2n+1, why 1? Because of +2 minus 1 हाइड्रोजन, एक हाइड्रोजन में निकाल दिया है, तो वहां पर एक हाइड्रोजन निकालने के बाद एक ही बचेगा, दैट इज व्हाई CnH2n+2. For alkane it should be CnH2n+2. For alkyl group CnH2n+1. Suppose that we have a 1 carbon, so how many hydrogen for this formula? So CH3. Why so? C1 carbon twice of 1 carbon, 2 hydrogen plus 1, that is 3 hydrogen. So called methyl. You know, 1 carbon called meth, and here is the alkyl. So 1, right? अगर इसका n कहते हैं तो क्या होता है? CH4 because of +2. So here second carbon, if I have to C2, then how much hydrogen is there? How many number of hydrogen? कितने हाइड्रोजन रहेंगे साथ में? For C2 hydrogen twice and +1, how much? 5. Right? So what should be the group name? 2 carbon alkyl group. What should be the group name? What should be the name for 2 carbon? That is ethyl. What? Ethyl group. Why so? Because of relation of 2 carbon. Similarly, for 3 carbon C3, then what should be the number of hydrogen? 7. 7. What should be the name? Propyl. Here is the ethyl. Suppose that we have 4 carbon. Similarly, and so on. 4 carbon. What should be the hydrogen number? 9. So what should be the name? Butyl. Butyl. Fine. So see again we have another rule. So longest chain, I had told you longest chain. Then after branching, what is the manner? Either they have a ring. These are the open ring called acyclic. If you have a ring carbon, that carbon arrange in between the ring, right? How? Suppose that we have a carbon, one carbon, then two carbon, three carbon, four carbon, whatever, five carbon, it may be six carbon, then this one. So this what? Complete cycle is there. So called cyclic one. Cyclic alkane. Cyclic hydrocarbon. Sometimes this is what? Acyclic. In case of cyclic, you must have another example of unsaturated hydrocarbon, so called. This is suppose that is. If you have a double bond here, somewhat maybe double bond here, whatever. So if I have a double bond, so this is what? Unsaturated, isn't it? Unsaturated hydrocarbon. But what type? It's a cyclic, isn't it? Earlier you have a double bond here, is the acyclic or non-cyclic. Single chain, open chain, no cyclic is there. But here you have a cyclic carbon atom in between the ring. If carbon arrange in between the ring, so called cyclic hydrocarbon, and two type of cyclic hydrocarbon, that is saturated cyclic and unsaturated hydrocarbon cyclic. Isn't it? Are you getting? So similarly, there are two type of ring again. One another is alicyclic. Alicyclic hydrocarbon. So in case of branching, in case of cyclic hydrocarbon, you have a two type of unsaturated cyclic hydrocarbon are two types. One is the aromatic, another is non-aromatic. Little later, or you can say in the chapter of benzene, we'll deal with the what do you mean by the aromaticity. So alternate presence of alternate double bond will tell you later on while going through the chapter of benzene alone. Cyclic unsaturated hydrocarbon are of two types. Cyclic unsaturated hydrocarbon are of two types. One is the aromatic, another is the alicyclic. So just you should take care of this name only, alicyclic hydrocarbon. Here is the unsaturated hydrocarbon cyclic, cyclic hydrocarbon only, non-cyclic. So I think you will have somewhat idea about the nomenclature. So take care of another example and give the answer. Suppose that you have for your test, just give me the answer for the following. Write the IPAC name for following. Just write down the examples. First is CS3. Just write down everybody. Second is and third is just write their name and give the answer. This is 1, 2, 3. Another you may have question number 4. Here is the 5 question for naming to you. Just write the proper name, IPSC name for this 5 questions. I will give the answer in the next lecture.